All right, guys, so in this lesson, we're going to be working with some absolute value expressions as well as equations. And so the first thing that I want to introduce you guys to, or I guess remind you of, is what it means to be an absolute value expression. So quick definition, if you see something like this with just an x, I'm just going to use a simple x on the inside. You could have numbers, you could have expressions, all sorts of things on the inside. What this means, this is the distance of x from 0 on a number line. So we treat it as a distance. So just to give you kind of a picture representation, let's say that we draw a little number line. I'm going to throw a 0 in the middle here. So x, we're thinking of it as representing like a number. You know, maybe it's 3 or 6 or something like that. So the absolute value represents the distance of x from 0 on a number line. So if the absolute value is x, what that means is that we could go x units to the right and land at x. So that would be an absolute value of x units. So this would be x units to the right, like this. Or we could go x units to the left, and if we go x units to the left, we land at negative x. All right, so this is also x units, but it's x units in the opposite direction. So that's why when you have absolute value, no matter what you plug into the inside, it comes out positive. So if we took the absolute value of negative x or the absolute value of positive x, either way, it's going to come back positive because we're talking about a distance, and distance can only be positive. Okay, so what that means is that the absolute value of negative x would come out as x, and the absolute value of positive x would also come out as x. Okay, so let's take a look at some examples. So example 1, we want to evaluate this expression given that x is equal to 4. So we start with this 2.7 plus, and then all I'm doing is I'm taking this x equals 4, and I'm going to substitute it into that expression. So I'm evaluating the expression by subbing in 4. So 2.7 plus, and then absolute value of 6 minus 2 times, instead of 2 times x, it's going to be 2 times 4. Okay, so think order of operations. I'm going to start to simplify it from the inside out. So on the inside, I start with multiplication. So I start with 2 times 4. So I'm going to keep this 2.7 plus, still absolute value 6 minus, and then 2 times 4 is 8. So I can simplify it that way. Jump to the next step. I can subtract now. 6 minus 8 ends up being negative 2. And that's inside of an absolute value sign. And then remember, when I take the absolute value, the definition is that I'm taking the distance. So absolute value of negative 2, that means the distance of negative 2 from 0. So that would come back being positive 2, the absolute value, the value of the number without the sign attached. Okay, so 2.7, so the absolute value of negative 2 is 2, and then that comes out to just be 4.7. So the answer that I would give for that first example would be 4.7. Okay, so that's the expressions. The expressions you're evaluating, you're simplifying, but you're not solving. Equations are what you solve. Okay, so this is the setup that you guys are going to have when we are dealing with any absolute value equations. Okay, so if you've got real numbers a and b, so again, when I write A or I write B, it's going to be representative of a number, not a letter. So it looks like this. If I have the absolute value of A is equal to B. So say I have that set up. So absolute value of A is equal to B. And then it's an equation. So it's something that you know is true. So if I know that this is true, then here's what I can say. Then I can say one of two things. Either A is equal to B. So that would be easy enough. If the absolute value is equal to B, then you could say that A equals B. Or this number on the inside could have been negative. Okay, so it could have been a negative A that was actually equal to B. Okay, so we do it like that. So we could say that A is equal to B or negative A is equal to B. So basically what that means is that whatever you have inside the absolute value, it could either be the positive value or the negative value. So that's what we're going to set up every single time we have one of these absolute value equations. So we're going to solve this. So we're using this main idea right here to solve these absolute value equations. So keep in mind that because you have a positive possibility and a negative possibility, you should always, always, always have two cases when you're solving absolute value equations. So I want you guys to make yourself a note of that. So you should always have two cases. Should always have two cases. So case 1 when it's positive, case 2 when it's negative. So we're going to use this format to set up our equations. So here's the first one. So absolute value of y plus 3 is equal to 8. So case 1, the positive example. So positive example is that y plus 3 is just exactly the same, and we set that equal to 8. That's case 1. Or the stuff inside the absolute value could have been negative. So we do that. So where I have an absolute value right here, I make the stuff on the inside negative. So I'm going to make the y negative, and then I make the plus 3 negative. So you change that inside to its absolute opposite, like this, and that's what makes it case 2. So I have case 1, case 2, the positive case, and the negative case, and then I can just solve those equations from there and get my two possibilities. So here, all I would have to do is subtract 3 from both sides. So y is equal to 8 minus 3, which is 5. Or, my second possibility, here I would start by adding 3 to both sides to get rid of this 3. And then I have negative y equals 11. And if I have a negative out front, I solve that by dividing by negative 1. So this ends up being y equals negative 11. Okay, so remember when you're checking your answers, you can do them in your head, you can do them in the calculator. It's easy enough to just plug these in just right in your head. So if I plug in 5 plus 3 is 8, and the absolute value is 8. So we know that that's a real solution, so we can box that one up. And then same thing over here. If I plug in negative 11 plus 3 is negative 8, and the absolute value of 8 is 8. So that is a solution as well. Okay, so that's how those work. You always have two cases, and you set up the two cases by just doing the exact expression that you had in parentheses, in the absolute value, and then the opposite expression. So with this one, case 1 is I just write exactly what I had in the absolute value, the positive version. So really, really important note, when I say the positive version, I don't mean that you make everything positive. So like the fact that this is negative, you're not changing it to a positive. When I say positive, I guess I should say the same instead. So let's say case 1 is the same, and then case 2 will be opposite. So let's use that language just to make sure things are a little bit more clear. So here, case 1 was the same. Here, case 2 was the opposite. So case 1, same expression that I had in the absolute value. And then case 2 will be the opposite. So opposite of 6 is negative 6. And then opposite of minus 4t is plus 4t. And then continue on. Plus 5 equals 0. So for both of these, I'm going to solve all the way through. I'm going to get t by itself, and that'll be my answer. So here I combine the 6 and the 5, and I get 11 minus 4t equals 0. I'm going to subtract the 11 from both sides. So these would cancel. I still have a negative 4t equals negative 11. And then divide both sides by negative 4. So real quick for our final answer, when I have a negative divided by a negative, it would make it positive. You don't have to turn these into mixed numbers. You can if you want, but I'm perfectly fine with improper fractions. All right, same thing over here. I have negative 6 and positive 5, so that combines to a negative 1. Plus 4t equals 0. Start by adding 1 to get rid of that negative 1. Then I have 4t equals 1, and I will solve for t by dividing both sides by 4. So I end up with t equals 1/4. So I've walked you through how to use your calculator to solve these. So just for the sake of going quickly through these notes, I will tell you that I promise these answers are correct. So when we check our solutions, we're going to go through and do that calculator check again. Okay, so these are your two answers for this. Let's do another one here. This one we've got variables on both sides. That's going to make things just a little bit more complicated. So two cases. Case 1, same. So keep the a plus 8 plus y the same. And then just anything that's not in absolute values, it's not changing. And then or case 2, which is the opposite. Opposite would be a negative 8 minus y. And then again, anything that's not in absolute values just stays exactly the way it is. And then we're just solving equations. Like once I get these written down, it becomes just like normal equation solving that we've been doing. So here I want to get the y by itself. So I'm going to subtract this y from both sides. So here I have just an 8 on the left equals 2y minus y would just be a y. And then minus 3. And now I need to get the y by itself. So I'm going to do that by adding 3 to both sides. So these will cancel. So I have 11 equals y. Now you can box that up. Some people prefer to see that the y is written first. It really does not matter either way. Again, you would be checking your solutions by using that calculator check, or you could write it out by hand. All right, I'm going to do the same thing over here. I want to get the y's on one side, so I'll start by adding y, and these will cancel. And I have negative 8 equals, when I add these together, I will get a 3y, and then minus 3. And I want to add this 3 so that I can move the number away from the variable. Negative 8, positive 3 is a negative 5, equals 3y. And solve for y by dividing this by 3. So the 3's will cancel. Y will be by itself. And again, if it makes you feel better, put the y first. That's totally fine. Otherwise, you can have number equals y. It doesn't matter either way. All right, so 2 solutions for example number 4. All right, last example, something very similar. We've got variables on both sides. This one's a little weird because I've got a 2 out front, but just remember, you're sticking with your 2 cases. Same, opposite. So case 1, if it's not in absolute values, it's not changing. So now, since there's a 2 there, I'm going to replace the absolute values with parentheses just to make sure that you remember to distribute. So case 1 is the same. So the 6x minus 2 just stays exactly the same as it was written right here. Or case 2, which is the opposite, 8x doesn't change. The 2 doesn't change. And remember, just to make sure that I distribute, I'll keep parentheses. This is the opposite case. So opposite of 6x, opposite of minus 2. So now I have a little bit of distributing here, and then I will be all done. I'll be able to solve for x. So here I'm going to start by distributing that 2. So I have 12x and then minus 4 if I distribute by 2. And then I want to get the x's by itself. So I'm going to subtract the 12x from both sides. So here, these will cancel. 8x minus 12x is negative 4x equals negative 4. Don't forget to keep the sign when you bring it down by itself here. And getting x by itself, I'll divide by negative 4. Negative 4 divided by negative 4 is 1. All right, let's check the other answer. Same first step. I'm going to distribute that 2. So 8x equals distribute the 2. And I'm going to solve the same way. Here I'm going to be adding 12x to both sides. I just want to be able to get that x by itself. So these cancel. 8 and 12 gives me 20x equals 4. And to get the x by itself, I'm going to divide both sides by 20. So this is reducible, so make sure that fraction ends up reduced before you call it your final answer. So 4 over 20, I can reduce down by 4, and I will end up with 1/5 as my final answer.